Hey, Algebra 2, welcome. Here's our first section of Chapter 7. Okay, Chapter 7 is going to be all about two new functions, the first one being exponential functions, okay? And so that's where we're going to be at for 7.1 and 7.2. 7.1, we're going to talk about graphing exponential growth functions, okay? So our objectives are to graph transformations of the exponential growth function and then use exponential growth to model compound interest. Okay, there's lots of other things we can use to model. We can use exponential growth to model in the world around us. But for this chapter, for this section, we're going to focus mainly on compound interest, money. Okay, so before we get there, though, let's talk about the the general form of the exponential. So our general form, this is going to be f of x is equal to a times b to the power of x minus h plus k. Okay, hopefully this AHK rings a bell. You know, that was from, it's kind of the same AHK from like our quadratic functions, the vertex form, right? And then also from the radical functions that we were graphing and the rational functions, right? They're always going to deal with our transformations, okay? And so typically what this graph looks like, okay, the typical shape of an exponential function is that it starts off pretty small and then it starts getting bigger gradually until it eventually starts just blowing up like this. Okay, and so it has most often just a y-intercept, but there are many exponential functions that have both intercepts, the x and the y. And then another interesting thing about this is that it has a horizontal asymptote. Okay, all exponential functions have a horizontal asymptote. The base one happens to be at y equals 0, but this can also be in other places as well. It's not limited, okay? So just as a reminder, A, that's our vertical scaling, right? It's our vertical stretch or shrink. And then remember, you know, when do we know which one is which? Well, if it's bigger than 1, if A is bigger than 1, it's a stretch. And if A is between 0 and 1, then it's a shrink, okay? And then we have H, which is our horizontal translation. I can't spell horizontal translation. Okay, shifting left and right. And then K is our vertical translation, shifting up and down. Okay, now B is not a transformation, so I'm going to put it to the side in a different color, but B does represent something. It's called the growth factor. And so if you ever do an application problem and it tells you this is the growth factor, then that is what B would be, okay? And then another thing is that our horizontal asymptote, so our HA, is always going to be y is equal to k. So whatever your k value is, that is your horizontal asymptote, okay? A few more things. Our domain, always negative infinity to infinity, all real numbers. So this one is an always type of deal. Okay, always. Now the range, we don't have a set one, so we're just gonna put it varies. Okay, it's gonna be different with every problem that we do with every function that we see. Okay, so let's just go ahead and let's graph one just to see. Oh, one final thing actually, because we're gonna talk about exponential decay in 7.2. So how do we know whether it's growth versus decay? Okay, if b is greater than 1, we have exponential growth. If b is between 0 and 1, you know, kind of like the difference between stretch and shrink. If b is between 0 and 1, then it's decay. Okay, and we'll revisit this again in 7.2 when we do talk about exponential decay. All right, so first example, describe the transformations happening in f of x is equal to 4 times 2 to the power of x minus 1 minus 3. Then sketch a graph, labeling the intercepts and horizontal asymptote, and then state the domain and range. Okay, so a few things we got to do here. Let's start with describing the transformations. Okay, let's write down the function down here. So we have f of x is equal to 4. Another way you're going to see this written is having the base, the 2, in parentheses, x minus 1, minus 3. And I'm just now realizing, I think I forgot to mention that up here. Okay, b is the growth factor, but more importantly, it's called the base. Okay, this stuff in the exponent, well, it's called the exponent. The stuff down here, the bigger number, is the base. Okay, it's the growth factor, but it's also called the base. Okay, so sometimes you might see instead of this dot, the base wrapped in parentheses, because now you see that the exponent x minus 1 is only applying to the 2, not to anything else. Okay, this is the way I personally like to prefer to write it, but sometimes like in a textbook that you might see, or later on you might see it 4 times, right? They're both the same. Okay, so based off of some of the stuff we already know, we know that our horizontal asymptote is y is equal to -3. Oh, and I kind of jumped the gun here. We need to describe our transformations. So do we have an A here? Yes, it's 4. Do you have an H? Yep, it's +1. And then our K is -3. Okay, and so what are these doing to our function? A equals 4, that's a vertical stretch by 4, right? It's a stretch because it's bigger than 1 by 4. H is equal to 1, that's shift. It's positive, so it's right 1. Okay, here it's -1, so since that matches up with the form, which is x minus h, h is exactly 1. Okay, and then lastly, -3, that's a shift downward, so down. Daub, I skipped a letter, down 3. Okay, and so what else do we need? We describe the transformations. Oops. We describe the transformations. Now we should sketch the graph so we can label the intercepts, right? Because we don't know what our intercepts are until we graph it. So let's go ahead and we'll use Desmos to help us out here. All right, so let's graph this. We're gonna need to do 4 left parentheses 2 right parentheses. And again, instead of doing the parentheses, I could have done 4 times 2, and then here I can do the exponent. Here, since there is lots of stuff in the exponent, there's addition and subtraction going on, or in this case, subtraction, you need to use parentheses. Otherwise, if you don't, here I'm going to do x minus 1. Okay, so it let me do it just fine. If I didn't use parentheses, if I did x minus 1, it automatically brings me back down to the base, to the regular, to the bottom, right? And that's not where we want to put the -1. Okay, that's just the thing that Desmos does. It's really only a Desmos thing. A graphing calculator wouldn't do that, right? So we'll need parentheses around that so it doesn't freak out on us. Okay, and then close. To get back down to the regular line, you can press this right arrow key. Okay, now we're down there. We can subtract our 3. Okay, so here's our graph. All right. And so it doesn't show it to us. It will never graph it for us, even on a graphing calculator. But notice that it does kind of follow the asymptote. Okay, if I graphed y is equal to -3, notice that our blue line, our actual graph, is never going to cross the green line, right? And normally that line would be dotted. Whenever you have an asymptote, you always make it dotted. Okay. And so here we can find our intercepts. We have one at 0, -1, and one at 0.585. Okay, not a nice x-intercept, but a nice y-intercept. Okay, so we can graph this. We can make note of these intercepts. All right, so let's go back. Okay, let's put our graph down. I need my white pen so you can see. okay? Mostly decent. And so 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm gonna write down my intercepts before I forget them. My x-intercept, that was 0.585 comma 0, and my y-intercept was 0 comma negative 1. I believe that, yes, is true. Okay. So I'm going to start by putting those down. So 0 comma negative 1. My tick marks are in scale of ones. Okay, and then another intercept that about halfway between 0 and 1, so like right here. Okay, and then I'm going to put my asymptote down because I want that to guide my function. So y equals negative 3. Label the equation, okay? Make sure you do that on your own paper. Y equals negative 3. And then I know my graph is kind of following that exponential shape, okay? So it's going something like this. Kind of follows along the asymptote for most of it, but then it shoots up like so, okay? Doesn't have to be a perfect graph, but that is pretty good enough, right? And so our intercepts, we have 0.585 comma 0, and then right here is 0 comma negative 1. Okay, and then lastly, our domain and range. Let me give myself a little more room here. Okay, domain, the same, negative infinity to infinity, not going to change. What's our range here? Okay, we're reading from bottom to top. Nothing's going to go past this asymptote. It's going to stay right here, right? There's not going to be anything on the other side. It's going to follow along the asymptote and then start shooting up. So the smallest value is negative 3. But our graph doesn't touch negative 3. It only follows alongside it. So I'm going to put a parenthesis at negative 3. And then it goes off to infinity. Okay. All right, so that's one example of what the range could look like. And there is the problem, right? We described our transformations. We labeled our horizontal intercept and our I'm mixing up all my words. What's wrong with me? Our horizontal asymptote and our x and y intercepts. Okay, and then we wrote down our domain and range. Let's do one more, and then we'll talk about compound interest for a bit. Okay, describe the transformations happening here in our function. Sketch a graph, same exact steps, right? So let's start by describing our transformations. So we have, we'll write down the equation again down here to make it look. Okay, so negative 3, 4, here's that parenthesis business I was telling you about, x plus 1 minus 2. So my a is negative 3. My h is negative 1, right? Because it's plus 1, I take the opposite. My k is negative 2. Oh, everything's negative, right? Okay, so there's two things happening with this a, right? Vertical stretch by 3 and then vertical reflection since it's negative. So vertical stretch by 3 and then vertical reflection as well since it is a negative a. Okay, h being negative 1, that's going to be a shift to the left by 1 and then shift down by 2. Okay, based on our k. And then our horizontal asymptote, since that is our k, is negative 2. Y equals negative 2. All right, so now we've described our transformations. Let's put this in Desmos and see what it looks like. Okay, I'm going to get rid of these two. And so I'm going to do negative 3, left parentheses, 4 to the power of, using this a to the b button. I'll need parentheses again because I have x plus 1. If your exponent was just x, or 2x or 4x, there wasn't x plus or x minus something, you don't need parentheses. But since it is in this case, we'll need it. X plus 1, close, right arrow to go back down to the normal line, minus 2. Okay, So here's our graph. Okay, it goes all the way down to -14 as the y-intercept. Okay. And then our horizontal asymptote is y equals -2. Y equals -2. And then I can make this dotted. All right. And so look, yep, our exponential function follows along this asymptote, but now it's going downward because it got reflected across the x-axis. It got reflected up and down, right? And so even though like this doesn't look like growth, right? Because growth we think of getting bigger, right? It's growing more negative. So it's kind of another way to think about it, right? It's kind of starting here and then growing in the negative direction, okay? And so there's our graph. We notice that you don't have an x-intercept, right? Because it's on this side of the asymptote and it's not going to cross it, okay? Sometimes we're allowed to cross a horizontal asymptote, but the exponential function never does, okay? The only thing we have is a y-intercept at -14. Okay, so let's try drawing this really quick. So we really only need the bottom half of the coordinate plane, right? So we'll do something like this. I think that's all I need. I hope that is true. Trying to draw as straight a line as possible. Okay, and I'm gonna scale this by 2. So -2, 4, 6, 8, 10, 12, 14. Okay, so I didn't need to go that far. We can chop it a little bit. Okay, and so we have a horizontal asymptote here at -2. Label that y equals -2. And then we had an intercept here at -14. Let me just make sure that that is -14. 4, 6, 8, 10, 12, 14. So right there. And then our graph was following the asymptote. And then it eventually started growing more negative, more negative, more negative until it crosses there and it keeps going like so. Okay. So there's our graph, right? Not a lot going on there except for the asymptote and the intercept at 0, -14. But that's okay, right? They're not always going to have an x-intercept, and that's because of the asymptotes. All right, so x-intercept tell me that there is none, right? And then you're going to prove it to me by doing your graph. Y-intercept, 0, -14. Okay, and now last part's domain and range. Domain, same old thing, negative to positive infinity. And then range, notice how it's a little flipped here. I don't start at the asymptote and then go up. I'm actually starting down here in the negative infinity, and then the highest I go is -2. So this one goes from negative infinity to -2. Okay, so it really is a matter of looking at your graph, okay? All right, so now let's talk about compound interest. Okay, sorry, I had to check to make sure that I was sharing my whiteboard. Sometimes I forget to switch from Desmos to whiteboard. Okay, so compound interest. Okay, what is compound interest? Well, think about just what is interest in general, right? When you borrow money or when you put money in your savings account, there's this thing called inflation, right? The dollar loses value. I'm not an economist, so I don't know exactly how that works. But over time, the dollar loses its value and it just fluctuates, right? Sometimes it loses its value, sometimes it gains value, whatever, right? And so the idea of interest is to kind of account for that, right? If I give my friend $20, I'm just going to tell him like, pay me back $20. I'm not going to ask for extra money on top of that, right? But the bank is not is not your friend. They're going to ask for interest, or they're going to give you interest if it's a savings versus a loan, right? And so that kind of takes into account the idea of this inflation. I'm going to lend you money, but the $200 I gave you right now is not going to be the same. It's not going to be worth the same in 5 years or in 10 years or in, whatever, right? Whatever time period. And so interest helps account for that. I'm going to give you $200 now, depending on how long it takes you to pay me, you're going to pay me a little bit more because my money's not going to be worth as much in 10 years. And so compound interest helps you account for that. There's a thing called simple interest, and there's also a thing called compound interest, which we're going to talk about. So a formula to calculate compound interest is this. Okay, A is equal to P parentheses 1 plus R over N to the power of NT. Okay, let's talk about what each of these letters mean. A is our final amount. Okay, that's the amount of money that we end with. Our P officially is called the principal, spelled like this, but really it's another word for starting amount. It's your initial amount. How much money did you put in that savings account to begin with? How much money did you owe me to begin with, etc. R is the interest rate, and you need to plug it in decimal form, okay? Because our interest rate is going to be given as a percentage, okay? Given as percentage. Want, okay? In problems, I'm going to give it to you as a percentage. You're going to want to make sure it gets plugged into the formula as a decimal, okay? N is the most wonky variable out of all of them. It's kind of the weird one. It's kind of long defined. It's the number of times you compound in a year. We'll talk about that in a little bit. And then T is the number of years, okay? All right, so what does N mean by that? Well, N, when we talk about compound interest, we're compounding this interest. You know, there's a certain frequency that we compound it, okay? Meaning that there's a certain frequency that the interest rate is applied to on your money in 1 year, okay? Sometimes it's only compounded annually. I'm gonna do this in yellow. Okay, so if it's annually compounded, N is going to be 1. If it's semi-annually compounded, meaning once at the beginning of the year, another time halfway through the year, that's 2 is our N. Quarterly, okay, every quarter it's compounded. That's N is 4, since there's 4 quarters in a year. Monthly, ooh, I promise that looks like, I promise that's monthly. That just looked weird. N is 12 because there's 12 months in a year. Weekly, you won't always be given this. You won't be given it too often, but in case you do, it's about 52, so we'll use 52. And then daily, not including the fact that there's leap years, it's just 365. Okay, so you're looking for these keywords in these problems to figure out what your N is, right? So if it says compounded quarterly, that means that the interest is applied to your balance every quarter, as opposed to just once a year, okay? So let's see what all that means in a problem. So last example, you deposit 4,000 into a savings account that pays 2.92% annual interest. Find your balance after 5 years when you compound A quarterly and B daily. So we're going to do this twice, okay? Using our formula, let's write down the formula. A is equal to P 1 plus R divided by N to the NT power. So what's our P here? 4,000, that's how much we start with. Our R is 2.92% in decimal form is going to be, move it twice over to the left, 0.0292. Okay, so 0.0292. Our N for part A, I didn't write down part A here, so let me write down an A. For part A is going to be quarterly, so our N is 4. And then our T is 5. Okay, so A is equal to 4,000, 1 plus 0.0292 over 4 to the 4 times 5 power. Okay, there is the setup. You'll need your calculator to find the answer, okay? And so let's put it in decimals, okay? And you can use your own calculator as well. but here, since I already have it open, I'm just going to use Desmos. Okay. So clear this stuff. I had 4,000 left parentheses 1 plus, I'll need to do the division symbol to open a fraction, 0.0292 divided by 4. Use this right arrow key to come back out, so you can close parentheses. Use this a to the b to get into the exponent. Okay, sorry, I was a little worried that I wasn't sharing Desmos, but I am. And then our exponent for this one is 4 times, actually just kidding, don't want to do it that way. If you do 4 times 5, it'll take you out of the exponent. So to stay in there, we'll do left parentheses, 4 times 5. Okay, so that's how much we have after 5 years, $4,626.33. Not a terrible amount, okay? Especially because what's happening here is you're just putting $4,000 in your savings account and you're leaving it there. You're not depositing any more money, okay? So that's actually not bad for you just leaving your money there. $4,626.33, approximately, because that is not the exact value we got. We got a bunch of other decimals with it, right? Okay, so now we do it again, but this time with the daily, okay? So everything is gonna stay the same. 4,000 is our P, our R is still 0.0292, our N is what changes. That is now 365. And then our T is still 5. Okay, so we have A is equal to 4,000. 1 plus 0.0292 over 4, not 4, over 365, because that's our N, to the 365 times 5 years. Okay, so now let's go back and do it in Desmos, recalculate this new value. All I have to change is my denominator here, so I can press onto that, delete 365. And then change my exponent as well. Make this, instead of a 5, 365. Okay? And so here we have $4,495.55. I lied. I should have changed the 4 into 365. This should be 365 times 5. It's a good thing I caught it. I was like, why is that smaller than quarterly? That shouldn't have been smaller. We're good now. 4,628.76. So $4,628. Okay, approximately. $4,628.76. Okay. And so there's our answer. Notice how we got just a few more dollars, $2 and some change from compounding daily. Now, you don't have that choice when you go to the bank, but different banks compound on different periods. And so it kind of depends, right? The more you compound, the little bit more money you get. You're not going to get a significant amount more, okay? All right, that's good. There's one last thing I wanted to tell you about before I forget, okay? So think about your order of operations here. If I were to ask you to plug something in for X, if I asked you to plug in, let's say 0 to find the y-intercept by hand, that would be, actually I'm not gonna do 0, I wanna do something a little bit different. Say, let's plug in 1. So that's gonna give us f of 1 is equal to -3 times 4 to the 2nd power minus 2. Order of operations says to do this first, 4 squared times -3. Do not multiply -3 and 4 together first and say this is -12 squared, and so that's 144. No bueno, don't do that. Okay, order of operations, exponents come first. So do 4 times itself, so 4 squared, I almost said 4 times 2. Do 4 squared, that's gonna be 16 times -3, and then minus the 2, right? Just wanted to make sure I highlight that before I end the video, okay? Hopefully that sounds good. I'll see you in 7.2. Bye guys, have a good day.